So I want to go over these IR practice problems, and it may be a little hard to see on here, and I've tried playing with a few different ways to get this to show up effectively on video. Looks like this is going to be the best that we're able to do, because I'd like to be able to keep as many, keep both the spectra as well as the list of structures on the screen at the same time. So just kind of bear with me as I do these. Again, these may be a little small on screen, but we do the best we can with them. So our goal here is to determine which of the compounds in the box matches each spectrum. So if we start with our first spectrum, we can see that we have an alcohol here. And if you look at our list of possible compounds, we can see that there's 2 possible alcohols in the list. I'll highlight those in yellow. So we can see that we have 2 possible alcohols here. So the question then becomes, what's different between these 2 possibilities? Well, the one on the left we can see is an alcohol, but the one on the right also has an alkene. And so if we're going to have an alkene, we should see a peak here between 16 and 1700. Since there's no peak in that range, we can be fairly certain that that alcohol is not the correct structure. All right, if we move on to our second spectrum, we can see that we have, well, here's 1500, and other than the CH peaks, there's nothing here. There's no OH, no NH, no carbonyls, no alkenes, no alkynes, no nitriles. So overall, a fairly uninteresting compound, and we can see there's just the one choice here that has no other functional groups. In part C, we have what is most likely to be a carbonyl peak. It's at about 1704 wave numbers. So that puts it right in the range for a ketone. And we have just one ketone in our list of possibilities, which would be that one. And finally, our fourth one on this problem, the only peak of real significance is this one right here. And that peak comes in right around 2100. Now it's of medium intensity, and we know the things that show up around 2100 are alkynes and nitriles. So we have a nitrile here, and we also have a molecule that has an alkene in it. But that alkene, you'll notice, is terminal. And a terminal alkyne should give us a very strong peak here around 3300, which we don't have. Since we don't have it, we can be fairly certain that this is not the alkyne, and it is in fact the nitrile. All right, if we move on to question 2, same type of question. again, we've got a series of compounds and then 5 different IR spectra to look at. So what I'm going to suggest, because it doesn't seem to be working the way I'd like it to be, it's just the screen ends up being too small, is if you don't have your copy of this exercise out or open, you should do so, because I'm going to be referring to the compounds on that table, and that's the table at the bottom of page 6. So looking at this compound, the peaks that are of significance to me are this one, and as well as that one. And for some reason we're not drawing on here anymore. There we go. And what those peaks look like, we have a medium to weak peak around 2100, and then a very strong peak around 3300. So that combination of peaks suggests to me that we have a terminal alkyne. Also of significance to me is the fact that in this 16 to 1800 region, where we'd find our sp2 carbons, there's nothing there. So if we go to our list, we'll find that there's 2 terminal alkynes on the list. And those are the 3rd and 4th compounds in the top row. However, one of those compounds, the one on the left, also has a carbonyl. And so for that reason, we can rule that structure out. And therefore, we know that this spectrum has to be the compound I've drawn here. Our second spectrum really only has one peak that should jump out to us immediately, and that's this peak here. That's at 1727 wave numbers. And we know that that's going to be a carbonyl. The remaining question is, because that's in the range of an aldehyde, a ketone, and an ester. So which one is it? Well, the ketone and ester are actually fairly difficult to distinguish between in an IR spectrum. But the aldehyde, we know, gives 2 peaks, medium intensity around 27 to 2900. And if we look over in that region, we clearly see one of them, and the second one is there. It's overlapped by the CH peaks, but both of them are there. So we can be fairly certain that the carbonyl in this spectrum is specifically an aldehyde. And if you go to your list of possible compounds that are drawn here, down at the bottom right, you'll find just one possible aldehyde. And so we know that this has to be the answer. All right, our third spectrum, what immediately jumps out to me are these 2 peaks. And given their intensity and where we find them, that says that our molecule has to have a primary amine. And there is only one primary amine on the list. So just on the basis of having identified that, we know that this is our correct structure. Our next one also has those two peaks, but not nearly as pronounced. But that would suggest to me that we are again looking for another NH2 group. And at the bottom right of our choices, we have an amide that has a NH2 group attached. And then finally, our last one on this part is this spectrum. Only one peak of significance here, which is this peak. 1687 wave numbers. So we're looking for either a carbonyl with a bunch of conjugation, and there really aren't any among this group, or more likely then at that point we would be looking at the one and only alkyne on the list. Alright, so now we'll go on to the last set on this practice sheet. So you'll need to bring up the table that's at the end of the document on page 9. And we start in this first one with this medium intensity single peak up above 3300. So that indicates, given that it's not a highly intense peak, it's more likely to be an amine than an alcohol. But also, given that there's only one peak, we know that it's likely to be a secondary amine. We can also rule out anything that has a carbonyl in it. So we're looking for the one and only option on this list that has a secondary amine. Which is that compound. Now this is a direct contrast to the next spectrum, which clearly gives us our primary amine pattern. So in the primary amine, we're looking for an NH2 group, and again, there's only one option that contains that. Then as we continue down, this is our peak of significance. It's a carbonyl, and it's showing up at 1683. So our first instincts might be to look for an alkene, but that shouldn't be what we're looking for. This peak is in fact too strong to be an alkene. So at that point we might be looking at amides, because this is directly in the range for an amide. And we do have one possibility. Which is that. But an amide, such as this one, this one has an NH group. And it's very, very clear that there's no NH bond in this IR region. So we can eliminate that amide as a possibility. So our next most likely scenario is that this is a ketone that has some sort of electron donating group next to it. And at the top right, we find that exact structure. We have a ketone that's conjugated to an aromatic ring, and so through resonance, we'll bring the peak to lower wave numbers. Now, what would happen if that carbonyl hadn't been conjugated to the aromatic ring? Well, if it wasn't conjugated, it would show up at higher wave numbers, such as 1716 that we see in the last spectrum. And so at 1716, we know this is most likely to be a ketone that's not conjugated to a carbonyl. And then finally, we go back up here. We have our sp carbon, a nitrile or an alkyne. In this case, we know it has to be an alkyne because of the choices I gave you for this question. There are no nitriles. And then this peak here tells us that we have a terminal alkyne. Although it turns out there's only one alkyne on the list at all, So as soon as you had identified that, you would have known it had to be this compound here.